Hello everyone, welcome to today's lesson on applications of trigonometry. So for the last few lessons, we worked a lot with trigonometry, right? We worked with find the angle of a triangle and find the missing side length of a triangle. So now this time, instead of actual triangles, we are actually gonna put into word problems. Right? So we're making our own triangles in a way. Okay, so let's look at this problem here. And so from a point that's 220 meters from the Empire State Building, a torus measures the angle of elevation to the top to be 60 degrees. Right, so this is a important concept to know. Right, we got two different angles that we can use to describe something. There's the angle of elevation, right? That's the angle between a horizontal line to the top of an object. I can think of it as an object here, right? From the base of the object to the top of the object. That is the angle of elevation. And angle of depression, right, if you can imagine your sight line here, right, the angle of depression is below the horizontal right here. Right? Angle of depression, it's less common, but you will see where we actually get to use it. But anyways, just like with other word problems, it's always easier to make a graph out of it, or make a picture out of it. Alright, so we have our Empire State Building here. Sure, something like that. Right? And we're saying that from a point 200 meters away from Empire State Building, so we got a torus here. So this right here is 220 meters away. The angle of elevation measures to be 60 degrees, right? So from the ground to the top of the Empire State Building, this angle here is 60 degrees. Right, and the question is asking us to find the height of the building. Okay, so which means that we're just trying to find h here, right? The height of the building. And as you can see here, this is a triangle, right? This is just a triangle here, 60 degrees, 220 down here, and a missing side length of h. And then from there, we just use our trig identities, or trig ratios, right? This is our angle in question. That's our right angle here, right? Which means that this is the opposite side, and that's the adjacent side to the 60 degrees. Right? And for that, right, remember our ratios of SOHCAHTOA. In this case, we'll use tangent because it's opposite and adjacent. So tangent of 60 degrees is opposite over adjacent. H is just we multiply both sides by 220. Put in a calculator, we'll get 381.1 meters, right? Which is around how high it actually is. Right? So remember, we are looking to round all the answers to the nearest tenth. So we stopped at 381.1. Okay, if you got a different answer, that means your calculator is in radian mode, make sure it's in degrees. Okay, so now a kite is 30 meters off the ground. The angle the string strikes with the ground is 39 degrees. How long is the kite string? Okay, so we got a little guy. We got a kite here. Oh, haven't flew a kite in a while. That's always fun. So we got a kite here. Right. We know that it is 32 meters on the ground. And we know that the string between the kite and the ground is 39 degrees. Okay, so now we want to ask how long this kite string is. Let's just say it's x here. Well, actually, let's do s for string. Why not? Okay, so once again, we have our triangle here, right? 32 meters here and an s here. So as you can see, that's the opposite to the angle. That's the hypotenuse, because it makes a right angle here. Opposite of hypotenuse, that's sine. 32 over s. Multiply both sides by s to get rid of the fraction. Divide both sides by sine 39 to isolate. which is 50.8 meters rounded. I just like that. Oh yeah, guess I should highlight this again, because we're looking for the length of the chi-string. Okay. The road rises 1 meter for every 15 meters along the road. Right, what's the angle of elevation of the road? Okay, so now looking for angles this time. Right, so it's saying that when the road goes every 15 meters along the road, it rises up by 1 meter. Right, which means that every 15 meters we go on the road, right, we go up by 1 meter. Right, just like that. And that is our triangle. Just like that. Alright, so for every 15 meters along here, we go up by 1 meter. Right, so this is what it will look like. Of course, we'll form a right angle here, and this angle of elevation is our theta. Right, so from this angle, this is the opposite, that's the adjacent, right? And remember, if you're looking for angles, we use the inverse ratio. Like opposite and adjacent as tangent, we use the inverse ratio, which is 3.8 degrees. Right? Just like that. Okay. So now, this question, right away, we know what we want to try to find, right? Find the area of a rectangle for the diagonal of 20 meters. Okay, so let's draw that out first. So we have a rectangle. Right. It has a diagonal of 20 meters. So this right here, the diagonal is 20 meters. Right. And the angle between the diagonal and the longer side is 25. Right. So this right here is 25 degrees. Right. Now we want the area of the rectangle. Right, of course, the area of a rectangle is just the length times the width. Right, so we have the length here and the width over here. Okay, so we got two pieces of information, right? So that's our angle here. That's the opposite, that's the adjacent. Right, so first for the width, right, we have the opposite in the hypotenuse, which is sine. Width over 20, so width is just 20 times that. Right, and then the length, right, is adjacent in the hypotenuse, so it's a cosine. Right, notice here, I actually do not calculate this right away, right? Right, I'm just gonna leave it like this. 20 times cosine of 25. And the reason is, right, when we calculate the final thing, we want to use exact numbers, right? So the area, which is length times width or width times length, right? Right here, I'm using the unrounded numbers. Right? If you multiply all that out, right, you get 153.2 meters squared. Alright, so make sure you do not round the numbers first, because if we round the numbers first, right, in a calculator, the width, right, so this right here is 8.4, and this right here is 18.1. So this is when I rounded both of those to one decimal place, and now if I'm about to multiply both of those, alright, if I multiply those, I would get 152.0. Alright, so again, as you can see here, if we rounded early, right, we get a different answer than if we just put everything together. Right, so don't ever round early, just put everything, multiply everything together, so you get the exact same decimal. Okay. So the next view, this is getting into the more proficient extending territory, right? But I want to show you some harder problems. So Angle of elevation to the sun is 58 degrees. And if Mr. C casts a shadow of 1.07 meters, how tall is Mr. C? Okay, so we know right away we're looking for the angle of elevation here. Okay, the angle of elevation. So here's the sun. Alright, so this is 58 degrees. This is from the first piece of information here. We got an angle of elevation of 58 degrees. And now, if Mr. C casts a shadow of 1.07 meters, that means that Mr. C must be here. And there's a shadow here. Right, and the shadow here is 1.07. Alright, so that's how we will make this triangle. And of course, we're looking at something like this. And we want to find out the height of Mr. C. Right, this is across from the angle, so that's the opposite. And that's the adjacent, so we use tangent. Opposite over adjacent. Right, so once again, just like with a lot of things in math, the calculation is the part we've been practicing the most with. It's mostly the setting up that's the harder part. 1.7 meters, which is around there. I'm 173 centimeters. Okay. So now let's try to work with angle of depression here. Right, a pilot required to approach YVR, that's our Vancouver Airport, and an angle of depression of 8 degrees. If the plane is traveling at 10,000 feet, right, what's the horizontal distance from the airport that the plane should start descending? Okay, so let's get our airport here. Sure. Oh, just a little windsock, right? Airports have that. Sure, that's our YVR here. Right, and we have an angle of depression this time. So we have a plane here. Right, remember, angle of depression, right, it is when that's the angle below the horizontal. And this is the object. So the angle between this line and the horizontal. Okay, let me just make it slightly more straight. Right, that right here, that's the angle of depression. Right, again, that's the angle between the horizontal of the object and the line towards the, it's between the horizontal and then the line to the object. Right, horizontal of the plane and the line to the object, which is YVR. 8 degrees. Right, we know that the altitude here is 10,000 feet. Okay, so now what's the distance here? Right. How far is the horizontal distance when the plane should start descending? Okay. So alternatively, there are two ways to go about this. Right, we can either notice here that, oh, come on, give me a rectangle. There we go, that's a rectangle there. Okay, we can either notice here that, okay, if this is 8 degrees here, I want distance here, right, we notice here that this forms a rectangle, which means the top here must also be D, and then this side length here is also 10,000. Right, so we can see here, that's our angle, that's the opposite, and then that's the adjacent. Right, so we can use tangent here with 10,000 being the opposite and then the D being the adjacent. Or what we can notice is that this right here must be a right angle. So this angle right here must be 82 degrees. Right? And then we can use the tangent of 82 with the opposite of D and adjacent of 10,000. Right, so both will be the exact same answer. Either tangent of 8 degrees is 10,000 over D, or tangent of 82 degrees, that's D over 10,000. Right, both will be the same. Okay, but for this one, I'm just going to use tangent of 82. Opposite is D. Adjacent is 10,000. Times that, which is 71,153.7 feet. Okay. A ship is sailing off the coast. At a certain point, the navigator sees a lighthouse north of the ship. Okay, so just a quick little compass here. North is up, south is down, west is left, east is right. Okay, so we have a lighthouse here. Okay, so at one point, the ship is, there's a lighthouse north of the ship like that. And then after sailing 4 kilometers to the east, so 4 kilometers to the left, right, the angle between the path and the line of sight to the lighthouse is 39.5. Right, just like that. And now from here, how far away is the lighthouse? Right, so now this is the D here. This is how far the lighthouse is. Right, so in this case, we have adjacent and opposite, or not opposite, hypotenuse, which is cosine. 4 over D, multiply both sides by D. Five on 2. Okay, just like that. Okay, this is the next two questions are more into the extending territory now. Right, the area of this triangle. Alright, so just with all triangles, we want the height and the base. Right, the area of a triangle is 1 over 2 times base times height. Okay, so we can see right away, we can easily find the height, right? Because the height here is, we have 68 degrees here and a right angle. So that's the hypotenuse. And this right here is the opposite. Right, so height we can do right away. So the opposite of this angle is h, hypotenuse is 5. So h is just 5 times sine 68. Okay, so remember, we do not calculate this yet. Or we do not round this yet, but let's highlight it. That's one piece of information. Okay, how about the base? Now notice here that this is not a right angle here, right? So we have to we can't really find a base directly by using this triangle. But we notice here that we got 2 separate triangles here, right? If we just add up the base of this triangle and the base of this triangle, we can find the total base of this big triangle. Alright, so we can actually now split this into B1 and B2. Right, the 2 different bases of the triangle. Okay, and now if you want to find out what's the base of this triangle here, right, once again we use this angle here. Right, this is the hypotenuse and that must be the adjacent. Right, so the first base is just 5 times cosine of 68. Okay, the second one's a little different though. And for the second one, we notice here that we do have a right angle here. We have a 9 meters here. However, we don't know what this angle is. Right, because we know what this big angle is, that's 80 degrees. But we don't know what's this small angle here. Right, but luckily, we can find out using this one. Right? If we look at this triangle here, if this is 68, that's a 90 degrees. This small angle is just whatever's left, right? So this small angle here is 180 minus 68 minus 90. Alright, so that's this angle right here. on the right side. Okay, so which means that this angle then on the left side, right? We know this total angle is 80 degrees, right? And we know this angle here is 22. So then this angle right here must be 80 minus 22, which is 58 degrees here, right? So then from there, we know that this angle is 58 degrees. We have the hypotenuse, we have the adjacent, right? So cosine 58 is adjacent over hypotenuse. Oh, sorry, hold on, what am I doing here? We already found that. Sorry. Okay, we have 58 degrees right here. Okay, once again, we found that. We have the hypotenuse, and now we want this one. We want B2. We already found the H, but we want the B2 now, which is the opposite. So, sine of 58 is B2 over 9. So B2 is just 9 times sine 58. Alright, that's everything we need. So the area of a triangle is 1 over 2, right, times the base. Right, we know the base is B1 and B2 added together, right? It's those two added together for the big base here. So we have B1 and B2. Right, again, notice how I'm using exact numbers. I'm not rounding anything. Alright, so that's the base here, times the height. Right, the height which we found was this. Hold on a second, is that sine? I feel like it's not sine, is it? Oh no, there is sine, sorry. I was looking at the wrong, yeah, 68. Okay. And when we multiply all that out, we get 22.7. Okay, so once again, just be careful here. We want to make sure that we save all the value until the end. Okay, here's another hard one. Right, area of the shaded region. Right, we know this right here is a circle, right? Area of a circle is pi times radius squared. And for the shaded region, we just need to find the area of the circle and then subtract it by the area of the triangles. Right? So now with the triangles, we can kind of split it up. Wait, let's get one of the triangles. Okay, so we have a line down the middle. And this is 53 degrees. And the last piece of information we know is that the radius of the circle is 5 centimeters. So which means that this diagonal side is 5 centimeters. Okay, so we have all the information that we need, right? We can first find the area of this triangle. So which means that we need to find the height of this triangle. And I also need to find the base. I want to find the base of this triangle. Okay, but we also notice here that this triangle here is just made up of the same triangle twice, right? So the height we can find by looking at this one here, right? The height, this is 53 degrees. The height is the opposite, that's the hypotenuse. But for the base, we can only find this length right here. Right, because then looking at this angle, once again, this is the angle, that's the hypotenuse. This right here is the adjacent. So we can find how long this is. which is only half of the base of this big triangle. Right, so what we can do instead, actually, is let's find the base of just this segment here. Right, because then we can multiply the base by 2 to get the base of this big triangle, or like the total base of the big triangle. Okay, let's find the height first. Okay, so this is the opposite, that's the adjacent, hypotenuse, so that's sine. Height is 5 times sine 53. First information. Second, let's find the base. Okay, so the base of this triangle, of the left smaller triangle, we need cosine, because that's the adjacent. Okay, so this is the base of the smaller, or this is the base of just this triangle. So now the base of this bigger triangle here is just 2 times that. Alright, so 2 times the base is just 10, right? 10 times cosine of 53. Alright, so the area of this triangle is 1/2 times the base here. Right? The base here is 2 times this. Times the height. Alright, so just make sure of that, okay? So the area of one triangle, and since those two cancel out, is just b times h. But because here we have 2 triangles, right? So the area of one of this triangle is actually just base times height, right? Not, or 1/2 base times height, because again, this base we found here is, the bigger base is 2 times the smaller base that we found. So the total area now for the shaded area is area of a triangle, which is pi 5 squared, that's the radius, minus 2 of the areas of the triangles. Right, so it's 2 times base times height. Again, the area of one triangle is just base times height. So 2 of those triangles here is 2 times base times height. Right, so it's 25 pi minus 2 times the base times the height, which gets us 54.5 centimeters squared. Okay, just like that. Once again, this is an exciting question. This is very difficult. But that's how we will solve questions like this. Okay, but with that being said, get used to questions with just one step first, right? The first few questions are a good exercise to warm up, and then try your best and tackle some of the harder questions on your own. Okay, so with that being said, good luck practicing.